Okay, so this problem asks us, the figure shows a switch alternating position between A and B every 2 seconds. Therefore, charging for 2 seconds and discharging for 2 seconds. And then discharging again. Okay, so it's just going back and forth. It says determine the VC at times 2, 4, 6, and 8 seconds. Assume that the first stage V of C is equal to 0 volts. Alrighty, so we've got a couple pieces of information here that we can work with. First being, we know that V of C times 0 is equal to 0 volts. That's good for us. Now let's take a look at what this is going to look like when it's connected to A. So if it's connected to A, minus 10 volts. That'll, there we go. Okay. We have resistor R there. And then this is our switch connected to point A. All right. And what we need to do now is to find out how much it's being charged up over a period of time. Since we have this resistor here, we can go ahead and use the charging equation, charging discharging equation. So if I was to go write that out, so V of C of t is equal to V of C at infinity plus V of C initial minus V of C at infinity. Infinity e to the minus t over tau. Okay, so looking at this, we see that we have a couple things that we need to know. So it's, once again, it's the charge at, or the voltage at infinity, voltage at time 0, and then time, and then tau. So fortunately for us, this circuit, the tau equation is going to remain the same because this is the A circuit. The B circuit looks something like this. And we'll just do that. Okay. So now it's the same resistor on both of these circuits. So charging or discharging, we're going to use the same time constant. So knowing that, if we were to go ahead right here and look at the time constant, tau of C is equal to R equivalent of C, we have R is equal to 1 mega ohm, and the capacitance is equal to 1 microfarad. So when we do that math, these units will cancel out, and we will get a value of 1 second for the tau. So now that we have that, let's go ahead and look at the A and the B circuits. So if we initially had 0, and I'll just go ahead and drop V of C here, V of C there. So if we go ahead and look at the A circuit first, because we're going to start charging. So we're going to go that way first. Then we're going to go this way second. Then we go that way third. So we're just going back and forth between those two terminals. So we need to start charging first. So I'm going to put the first equation down. So let's see. If we were looking at the first equation here to see how much it's going to charge up over a period of 2 seconds, we need to first look at what we have and what we don't have. So we already figured out tau. We have time. We have V of C initial. We just need V of C at infinity. Well, if we go ahead and let the A circuit run to infinity, me just 1 second. We'll get plus minus. Clip out. This was V of C. R. And then if we came in here and did the same exact thing. These are as time goes to infinity here. This one is charging. It's going to discharge. There we go. Okay, so if we look at the right-hand equation, we're going to see that if we do this loop here, where this is 10 volts, by the way, if we do the KVL on it, so KVL, if we let it run to infinity, we will get that -10 plus V of R plus V of C is equal to 0. Since no current is running through, this will go to 0. Therefore, V of C at infinity is going to be equal to 10 volts. So let's go ahead and look at the bottom equation. So this was for A, if we let it run forever. And then if we look at B, once again, this is time goes to infinity. Look at B. B is just going to be discharging forever. So if it discharges forever, it's eventually going to run out and go to 0. So now we have the final values for the infinities here. I'm trying to write these as best I can off to the side. All right. So now that we have those, let's go ahead and start just going back and forth with charging and discharging. So, if I write charge for 2 seconds, then VSC of 2 seconds is going to be 10 volts plus 0 minus 10 volts e to the -2 over 1. And this will give us 8.64 volts. We'll just call it that. Okay. So now that we've charged up for 2 seconds, then what we're going to do is now switch over to B and start to discharge. So we're discharging for 2 seconds now. Okay. And granted, so this is at time is 2 seconds. This will be a time at 4 seconds. But the thing is that we're only discharging for 2 seconds. While this is 4 seconds in the process, we're only discharging for 2 seconds. So we'll go ahead. Now, something to note though is that the V initial for discharging is going to be whatever voltage was in the capacitor when you stopped charging it up. Because now what you're doing is, so V of C of, I'm gonna write it out, infinity plus C 0 minus V of C infinity e to minus T over tau. Okay. We know that the V of C infinities are going to go to 0. And then we know the time is 2 seconds. The thing is, now we don't know what this V of C initial is, but it's going to be whatever value we had in the capacitor right before we stopped charging up. So if we go and write this out, so if we VFC discharged for 2 seconds, we would now get 8.64 e to the minus 2 over 1. To give us 1.17-ish. Yeah. 0.17 volts. Okay. And then if we charge again, so now we're going to go back and start charging again. Charge for 2 seconds. T is equal to 6. Then we will get VFC. We're going to charge for 2 seconds. Then now VFC infinity plus VFC initial minus VFC infinity e to the minus t over tau. And like we said, we already know if we're charging up, this is infinity is going to go to 10. Time is going to go to 2. Tau is going to go to 1 second. But the initial here is now going to be whatever we stopped discharging at. So that'll be 1.17 volts. So VFC for 2 seconds here would be 10 plus 0.17 minus 10 e to the minus 2, which would give us a value of 8.805 volts. Okay. Then finally, if we did it one more time, we discharge for 2 seconds. Now time is equal to 8 seconds. VFC for 2 seconds is equal to VFC infinity plus VFC initial minus VFC at infinity minus t over tau. That's 2 tau. So we know tau is going to go to 1. We know t is going to go to 2. Since we're discharging, we know infinity is going to go to 0. Infinity is going to go to 0. And then, like we said before, VFC initial is going to be whatever we stopped charging at. So VFC for that 2 seconds is going to be equal to 8.805 e to the minus 2, which volts. Which will give us 1.19 volts. So here, if I go and draw this little table for us. Time. And there we go. Okay. This is VFC. So if we do 2, 4, 6, and then 8, I know it's very nice looking. This is going to be 0.64 volts. This is going to be 1.17 volts, 8.805 volts, and then 1.19 volts. And this will be your final answer. All right. So, just charging and discharging, just flipping back and forth.